Hi Soters, I'm Sota Code, and in this episode we are going to talk about different areas of development for programmers. Let's dive right in. People have doubts at the time they want to start in the world of programming. There are too many options that can be massive for their minds. It was my case as well. It's not easy to choose. In this episode, I'll try to explain each field of development. It's important to mention that this choosing is not going to root you to this area forever. You always can learn a new skill and develop another area, and you will have already practiced some skills that are shared in these different areas. Okay, number one, web development. Okay, the first one is web development, which is obvious. It's the development of web applications. Actually, this area includes several sub-areas such as frontend, backend, architecture, cloud computing, and so on. In the end, many areas can be involved here, but I will try to explain it in an easy and very general way, being focused on frontend and backend development. First of all, let's talk about the first branch of web development, that's frontend. This is basically the visual area, what users see and with what they interact. For example, right now you're using a platform like Spotify or YouTube, and then you have to press a couple of buttons to arrive to the podcast and reproducing it. And it's here where frontend has the value. There are many factors involved here, like how easy it is to use, accessibility, and focused on what kind of people is targeted. Well, you can go deep into these aspects, but by your own. It's also something you learn on your way, so it's not a topic to get so serious in the beginning. So, what programming languages do we use for this? Well, the king of frontend is for sure JavaScript, and you can use different frameworks or libraries that make your task easier and more scalable, like React, Vue, and Angular. Other options are C# with .NET, Python with the Django, and Java with Spring. Then we have backend as the second big branch of web development. The backend is the part of a website or application that works behind the scenes. It is responsible for things like user authentication, data storage, and business logic, making sure everything runs smoothly. The backend sends and receives data between the database and the frontend, the part users see. And some examples of the backend in action are when you log into a website, the backend verifies your credentials. When you make a purchase online, the backend processes the transaction. And when you search for a product, the backend fetches the data from the database. There are four main components in the backend. One is the server, where the code is running. The second is the database, where we store and retrieve data. Then the third one is the logic backend that processes user requests, applies rules, and interacts with the database. It's the code itself. And finally, the fourth component is the API, that means application programming interfaces, that connects the backend with the frontend or other services. Let's break down some popular programming languages and frameworks for web development. Number one, JavaScript with Node.js. It is fast, scalable, and perfect for building real-time applications. Number two, Python with Django, Flask, or Fast API. Super simple and widely used, not just for web apps, but also for AI and machine learning. Number three, Java with Spring Boot, a powerhouse for large-scale enterprise applications. It is reliable and robust. Number four, C# with .NET Core, ideal for Microsoft-based systems and enterprise-level solutions. Number five, PHP with Laravel or Symfony, a classic choice for web development, and it's what powers platforms like WordPress. Number six, Ruby with Ruby on Rails, known for its speed and development, making it a favorite for startups. Number 7, Go or Golang. High performance and scalable. It's even used by big names like Google. Okay, let's talk about the second area of development for programmers. This is mobile development. Alright, mobile development is all about creating apps for smartphones and tablets, things you download from the App Store or Google Play. If you ever used Instagram, WhatsApp, or Uber, you've interacted with a mobile app. And just like web development, mobile development has its own branches and tech stacks. So there are mainly two ways to build mobile apps: native development and cross-platform development. Native development means building apps specifically for one platform, either iOS or Android. If you want an iPhone app, you'd use Swift or Objective-C with Apple's development tools. And for Android apps, you'd go with Kotlin or Java using Android Studio. The big advantage of native development? Performance. Since the app is built specifically for the platform, it runs smoother, loads faster, and feels more integrated. The downside, you'll need to write separate codebase for iOS and Android, which can take more time and effort. Now, if you don't want to build two separate apps, cross-platform development is a fantastic option. It lets you write one codebase that works on both iOS and Android. Here are some popular frameworks for this. Number 1 is Flutter. It uses Dart and was created by Google. It's amazing for smooth animations and building modern, beautiful UIs. Number 2 is React Native. This one uses JavaScript and was developed by Facebook. It's super popular, easy to use, and integrates really well with web apps. And last one is Xamarin, baked by Microsoft. It uses C# and is a great choice for businesses already working with .NET ecosystem. The trade-off with cross-platform development? You might sacrifice some performance compared to native apps, but the development time is significantly reduced. Alright, let's get into something really fun. Game development. If you ever played games on your phone, PC, or console, you've experienced the work of game developers. This field is all about creating interactive experiences from small indie games to massive AAA titles. Game development has its own unique set of tools and technologies. The most popular game engines include number 1, Unity. It uses C# and is fantastic for both 2D and 3D games. It's super versatile and widely used for mobile games and indie projects and even some console games. And then we have number 2, Unreal Engine. This one uses C++ and blueprints, and it's known for its jaw-dropping graphics. It's the go-to for high-end PC and console games. Number 3, Godot, an open source engine that supports multiple languages like C#, Godot Script, and C++. It's a great choice for developers who love flexibility and customization. Game development also involves different aspects like number 1, game design. This is all about creating the rules, mechanics, and overall experience of the game. It's the heart of what makes a game fun and engaging. Number 2, graphics and animation. This is where the game gets its visual polish, whether it's in 2D or 3D. It's what makes the game look stunning and immersive. Number 3, AI and physics. These are the behind-the-scenes elements that make characters behave realistically and objects interact naturally. It's what brings the game world to life. If you love storytelling, creativity, and logic, game development is an amazing field to explore. Okay, new topic. Let's dive into data science and machine learning, the dynamic duo behind everything from Netflix recommendations to spam filters. These fields are all about turning data into insights and teaching machines to learn from it. Data science is like being a data detective. It's about collecting, cleaning, and analyzing data to uncover patterns and trends. Data scientists use tools like Python, R, and SQL, along with libraries like Pandas and Matplotlib, to make sense of data and tell compelling stories through visualizations and reports. Machine learning takes it a step further by teaching computers to learn from data and make predictions or decisions. There are three main types. Number one, supervised learning, that is, learning from labeled data, predicting house prices, for example. Number two, unsupervised learning. This is finding patterns in unlabeled data, for example, for customer segmentation. And number three, reinforcement learning. This is basically learning through trial and error, for example, in self-driving cars. Popular tools include TensorFlow, PyTorch, and scikit-learn, which help you build and train models for tasks like image recognition, language processing, and more. From healthcare predicting diseases to finance detecting fraud and retail personalized recommendations, data science and machine learning are transforming industries. And with advancements in AI ethics and deep learning, the future is all about building smarter, fairer, and more transparent systems. Alright, let's shift gears and talk about DevOps and system programming. If you ever wondered how apps go from being a bunch of code to something you can actually use, this is where the magic happens. DevOps is all about bridging the gap between development and operations, making sure it runs smoothly in the real world. It's like being a conductor in an orchestra, making sure every part of the software delivery process works in harmony. So, what is DevOps? DevOps is a set of practices and tools that help teams automate and streamline the process of building, testing, and deploying software. Think of it as a way to make software development faster, more reliable, and less prone to errors. Tools like Docker, Kubernetes, Jenkins, and GitLab CI/CD are the backbone of DevOps. They help automate tasks like testing code, deploying updates, and managing infrastructure. But DevOps isn't just about tools, it's also about culture. It's about breaking down silos between developers and IT operations so everyone works together to deliver high quality software. Now let's talk about system programming. This is the low level stuff, the foundation that makes everything else work. System programmers write code that interacts directly with hardware, like operating systems, device drivers, or firmware. Languages like C, C++, and Rust are often used here because they give you fine-grained control over memory and hardware. If you ever wondered how your computer managed to run multiple apps at once, or how your printer knows what to do when you hit print, you can thank system programmers for that. It's not the flashiest part of tech, but it's absolutely essential. Next up, let's talk about something that's on everyone's mind these days: cybersecurity. In a world where everything is connected, from your phone to your fridge to your car, keeping our digital lives safe has never been more important. Cybersecurity is all about protecting systems, networks, and data from cyber threats like hackers, malware, and data breaches. Think about it. Every time you log into your bank account, send an email, or even swipe your credit card, you're relying on cybersecurity measures to keep your information safe. And as technology evolves, so do the threats. That's why cybersecurity is a constantly evolving field. It's a never ending game of cat and mouse between defenders and attackers. Let's talk about the key areas of cybersecurity. There are a few many areas you should know about. Number one, network security. This is all about protecting the integrity of networks and data being transmitted. Think of tools like firewalls, VPNs, and intrusion detection systems. They are the first line of defense. Number two, application security. This focuses on making sure apps are secure from the ground up, whether it's a mobile app, a web app, a desktop software. It's about building security into the development process. Number three, cloud security. As more companies move to the cloud, securing cloud infrastructure and data has become a huge priority. It's all about keeping your data safe when it's not stored on your own servers. And number four, ethical hacking. And yes, hacking can actually be a good thing. Ethical hackers, also known as white hat hackers, are hired to find vulnerabilities in systems before the bad guys can exploit them. It's like being a digital detective. If you are into problem solving and love the idea of being a digital detective, cybersecurity might just be your calling. Last but definitely not least, let's talk about embedded systems and IoT. This is where the physical and digital worlds collide. Embedded systems are specialized computers that are built into other devices. Think of the brains inside your smart thermostat, your fitness tracker, or even your car's navigation system. IoT, or the Internet of Things, takes embedded systems to the next level by connecting them to the internet. This allows devices to collect data, communicate with each other, and even make decisions without human intervention. For example, your smart fridge might notice you're running low on milk and add it to your grocery list automatically. Or a network of sensors in a factory might detect a machine that's about to fail and schedule maintenance before it breaks down. Building IoT systems involves a mix of hardware and software. On the hardware side, you've got microcontrollers like Arduino or Raspberry Pi and sensors that collect data. The software side, you've got programming languages like C, Python, and JavaScript to process that data and make decisions. But IoT isn't just about gadgets, it's also about the big data they generate. All those connected devices produce massive amounts of data, which can be analyzed to improve efficiency, predict trends, or even save lives. Of course, IoT isn't without its challenges. Security is a huge concern. Imagine if a hacker could take control of your smart home devices, or even a self-driving car. That's why cybersecurity is such a critical part of IoT development. There is also the challenge of managing all that data and ensuring devices can communicate seamlessly, even if they're made by different manufacturers. But despite the challenges, IoT is one of the most exciting areas of tech right now. It's changing the way we live, work, and interact with the world around us. And that's a wrap on our journey through the different areas of development for programmers. From web development to mobile apps, game creation, data science, DevOps, cybersecurity, and IoT. There is truly something for everyone in the tech world. Remember, choosing a field doesn't mean you're locked in forever. Programming is all about learning, growing, and exploring new possibilities. Whether you're just starting out or looking to pivot, the skills you gain in one area often overlap with others, making it easier to branch out. Thanks for having me in your day. If you have any questions, suggestions, or topics you'd like me to cover, feel free to reach out. You can find me on all social media platforms where I share this content. Just look for Sota Code or sotacode.dev. Alright, that's it for this episode. Until next time, keep coding, keep learning, and keep pushing forward. See you in the next episode.